Okay. Yes, perfect. Krishna, we are live on YouTube right now. I'm also sharing the link as well with you here. In case, I think it will be better if you also open this on your mobile so that, or else I can also send you on chat box as well. Don't worry. I will send it to you on a personal number in WhatsApp so that you will be able to see that as well. So that is just as a reference. If any students are asking questions, we can just go there and answer them as well.
Sure, sir.
Okay. Yes. Hello, Ranvijay sir. So just to share you that I have sent you a link so that you will be able to share that to your fellow students as well for the discussions today on the topic.
Okay, sir. Okay. Thank you.
So, like when I have shared some file to them through Navin sir, so I hope it has reached to the students.
Right. Okay. What was the document, Krishna?
Sir, nothing, sir. Like just a dry second in Excel sheet.
In an Excel sheet. Okay. If you don't mind, you can send it to me as well. We don't know whether it has reached to students or not. We could just share it to them as well. Maybe we can upload in a Google Drive and share the link in the chat box as well. The students can open it and keep it to them. Okay. You can.
Okay.
Yeah. Or else you send the file to me, maybe in chat box here. I will arrange an option to download. Okay.
Yes, sir. Like I have sent you, sir. Like
okay. In
WhatsApp I sent.
No problem. I will arrange it for you. 1 second.
Sir, one more question. Is there any change in YouTube live link or is it it's the same link that we have used for previous session?
So it is a different one. I have shared you in the chat box as well, the link.
Okay. Okay. I will share the difference. Thank you.
Sure, no problem. Okay, Krishna, I have shared you a link where we can also share the students as well on YouTube Live. I'm sharing it to you on the chat box as well. All right. So we have to just add that link in the YouTube Live so that students will be able to get a quick access to it, and they can. I'm also commenting that on the YouTube Live as well. Okay, great, Krishna. I think it's all set. I've shared the link to all the students as well.
Okay, sir. Thank you, sir.
Yes. So all the students has to just go there and download the file. Okay. Right, Krishna, I think we should be good to start because this is a live stream. The students can they can rewind and watch it as well uh, with the session as it goes backward.
Okay.
Right, Krishna.
Shall I start?
Yeah, you can get started, Krishna. So you have all the permissions to go ahead.
Okay. Hi, hello. Good morning. So, like as per like mentioned in the schedule, like we'll be discussing about like powertrain sizing. Okay. So we'll have some theoretical like aspects first. So we'll look through some of the concepts, and then we'll look into some calculation part with help of your Excel sheet. I hope like we have already received that. Okay. Yeah. So like briefly, I will just give my introduction. So before going into the session, okay. So myself, Krishna Sach, and I work as simulation engineer at Decibels Lab Private Limited. So yeah, like I'll quickly go to the content. Like what are the things we are going to discuss? So as we mentioned here, like first, like when we talk about powertrain sizing, right? Okay, sizing, or like we all like see that like many components will be involved. Let's say like if you talk about like motor or like battery or like transmission, like okay. So like in order to like size like motor, battery, or like we should be knowing what are the things has to be like considered, or like what are the let's say like component sizing like in terms of like motor. So you should be knowing the torque of your motor, like how much power it has to be produced, like rpm. Like to know these things, like what other parameters which influences them, that we should be knowing. Okay. So so to start with that, like we should be knowing all the basics of it, that is like what are the resistive forces. Like if we talk about like vehicle, what are the resistive forces will be acting over the vehicle, that will just look overview of it. And then we'll come to the driveline dynamics. So there will just go through the transmission system in overview, look into some part of the equations so that we can make use to uh, equations to size the components. Okay. Yeah. So with this, just go further. So here, like there are so many different approaches. What I'm going to hello, sorry. Yeah. Okay. Yeah. So like if you talk about the sizing of the powertrain, okay, there are like many approaches. Here, like we'll be discussing about approach called wheel to well analysis, like wheel to well. Okay. So this will be like your wheel side. You can see this particular block diagram, right? Okay. So let it be. This is whatever the vehicle longitudinal dynamics, like this is nothing but at the wheel side. Okay. This is your like source. Okay. So it is in like backward approach of estimating or like sizing your components. It means getting to know the things required at the wheel side. Okay. So if the wheel will be like rolling over your over the road surface, right? Some surface. So what are the things affecting for its movement? Like considering all these things, like what are the energy is required at the wheel side so that it will carry out the vehicle for the movement. So considering all the like requirements at the wheel side, we go on like estimating the like power required at the wheel side, and then with that we can estimate the power required for the motor, and then to the power required at the battery, kind of. Okay, so this is like a backward approach, you can say. So getting to know what, yeah. So like there are some basics derivation of the equation, like it is related to the vehicle, that will be like vertical, longitudinal and lateral. But here we only discuss about like longitudinal, because we are just concentrating on the front and the back motion of your vehicle. It means like in next direction itself. Okay, we won't be like concentrating on turning all this stuff. Yeah. So like here, this is a basic equation. Like we're just balancing the forces. Okay, so with the help of like Newton's equation, that is F equal to m into a, we'll be deriving the whole thing. So yeah, so if you see this particular equation, right, this is your like force required, and these are your like resistive forces. Okay, so with this like we can get to know like what is the required force. So I will be discussing like in detail, or like what is aerodynamic force, gradient, rolling, all this stuff. Okay, yeah. So don't worry about these particular equations for now. So here, like if I want to say the resistive forces, right? So if you consider a particular vehicle, okay, like there will be some restrictions, like a kind of offered from like from your body structure, which is coming to exposure with the environment condition. Let's talk about like aerodynamic force. Okay, so that will be one of the resistive forces which will be against your vehicle motion. And then there is like rolling resistance. It means wheel will be in contact with some surface, so there is always some resistance offered by road surface to wheel motion. So one more like resistance, and like gradient. If you're like trying to go for like uphill condition, you are going to put some extra effort, right? Like to like up like to move uphill the condition of your road, like in order to overcome this uphill condition. Okay, so like you are going to make use of angle, like the slope which is with respect to the ground level. Okay, so you are going to like need extra effort from your vehicle, like resist if any uphill condition. So a kind of resistance that we call it as like gradient force. Okay, so I'll just like try to draw it here. Okay, yeah. So like all these forces, right? Like if we talk about like gradient, uh, aerodynamic, and rolling resistance, all these forces, like they will try to restrict your vehicle motion. Okay, and we have to put acceleration force from our side so that it has to overcome and along with overcoming these resistance forces, well, like we had to reach some certain desired velocity, you can say. Okay, so like we'll discuss that point. Yeah. So yeah. So we just discussed about like what are the forces acting on your vehicle. So how they are going to contribute in what percentage? We'll just look into it. So if you see this particular wheel like pie chart, right? So you can see like 45% of it is contributed by the aerodynamic force, like some tire rolling, it is nothing but a lowering resistance, and rest others. Okay. So the major contributor is like aerodynamic force itself. And you can see like the force versus the vehicle speed. Like they like we have mentioned like rolling resistance, aerodynamic forces, all this stuff. Okay, we'll look into this graph in detail. Yeah. So here like we'll start with the rolling resistance. Like we define that like it is like a kind of when a surface is in contact with your wheel, there we going to like encounter that resistance. Okay, so what are the factors affecting the rolling resistance? So like there are many factors, like the tire pressure like is one of the factor, like which is going to affect. It is because of, so if you don't like mention sorry, if you don't maintain the proper pressure. Okay, let's say like if your tire is in contact, sorry, if the tire is completely flat, so if this is your width of your tire, okay, some like like some meter you can say, or like some millimeter. So if this is your width of your tire, so if the road is like completely flat, sorry, the tire is completely flat, the whole part of your like tire is going to come in contact with the road. So the contact area between the road surface, that is here, in terms of width, it's going to increase. So like this is a kind of how you had to maintain the tire pressure, or like how it's going to affect the rolling resistance. Again, like if you consider one more parameter, that is width of the tire. Like you guys might have seen like for some vehicles, like there will be like uh, less width of the tire, and like some amount of good width of the tire. So like the arranging of that, it will be like having their own advantages and disadvantages. But if you go on increasing like width of the tire, again the contact patch is going to increase, so it's going to affect the rolling resistance. Okay, so one is pressure and the design of your like tire, that also matters. Okay, yeah. So again, like if you see, uh, there is a term called a coefficient of rolling resistance, which is a constant term. So it's going to be like again varying with respect to the different velocity, or the car it increases at different tire pressures, how the changes in the rolling resistance. Okay, it's keep on like increasing. So yeah, these are like some parameters. So again, the CIRR like value is going to be varied with respect to different road surfaces. Okay, if you talk about like concrete or like other roads, like ordinary road, the sand, like it's going to vary. Okay, the values. So how will be like your rolling resistance? Okay, yeah, and the effect of your tire temperature on rolling resistance. So you can see, like as the increase in the tire temperature, like a lot of hysteresis losses is going to happen. Okay, so that's also is going to affect your rolling resistances. Yeah. So like we discussed about some parameters. Like one is with respect to the design of your tire, and the weight has a parameter. Even the weight also matters, uh, and the tire pressure, and one more like the material, like the surface material. Okay, and the temperature. So there are the material of the tube. So the earlier part, like we discussed about the road surface material, like concrete, sand, road, like kind of. So here you can see like different uh, tube, like material of the tires. Yeah. So this is about like rolling resistance. So we'll like just quickly look into the equation. So in order to calculate your vehicle, we can make use of this equation, that is CRR and GVW kind of. Okay. So here, like GVW is nothing but gross vehicle weight. Okay. Gross vehicle weight, it will be including gross vehicle mass is multiplied with acceleration due to gravity. So gross is nothing but vehicle mass plus driver or the passenger mass. So if you include like driver and passenger mass, it will give you gross vehicle mass. And if you multiply the gross vehicle mass with acceleration due to gravity, you will get gross vehicle weight. Okay. Yeah. So for the gross vehicle weight, you are going to multiply uh, CRR value, that is coefficient. So this will be your constant term in some generic equation. Okay. So this in reality, right, this is varying with respect to the pressure of your vehicle. Sorry, wheel means the tire pressure. Okay, and the velocity which you are moving in. You can see the other equations, like where it is dependent on pressure and the velocity. Okay, so yeah, it depends. But for our like further part of the calculation, we will be considering only this particular equation. Okay, yeah. So yeah, so this is about rolling resistance. Just try to note down the FR equal to CRR multiplied with GVW. So it will be Newton. Okay, the force. So let me clear all the diagrams. Yeah. Now, like one resistive force. So let me write it here itself. Rolling aerodynamic gradient. Okay, and one more like acceleration. We'll just look into it, how we can make use of this. So we have just looked into the rolling resistance. So we defined what is rolling resistance, and we also defined what are the parameters affecting the rolling resistance. Okay, and we also looked into the equation, how we can estimate or like calculate the rolling resistance. So the same thing, like we are going to look for aerodynamic force itself. Okay, yeah. So let me clear. So yeah, so we'll like we start with aerodynamic force. So if you want to uh, like say that like what is like aerodynamic force, like how it's going to affect on your or like to your vehicle body, or like how it's going to act as a resistance force to your vehicle, like we'll look into it. So like we'll come back to these equations later. So we'll just try to look into some parameters. Okay. So we all like studied like a drag force, right? Aerodynamic force, you can also like say that like a drag force. Okay. So like we already like get know that some concepts which we studied, 11th and 12th, like how we can like calculate the drag, like with the help of some principles like Bernoulli's principles, all this stuff. So how the air flow, like it's going to affect your vehicle body. Okay. So like let's say like if you're moving with your vehicle and you're going to expose your vehicle parts of the frontal parts, like kind of to your air molecules. So air molecules will be coming in contact with your vehicle. So they're going to offer some resistance to your vehicle movements. So that we can simply define it as a aerodynamic force. So what are the parameters will be involved? We'll look into it. Okay. Yeah. So if you see this particular equation, right? Here to calculate the aerodynamic force, that is, this will be like your constant value, and this is your rho, uh, that is A is nothing but area, CD and V square. So rho is nothing but air density, uh, and A is nothing but area. Area is like frontal vehicle area. Okay. Yeah. And CD is nothing but like coefficient of drag, and V is nothing but like velocity. Okay. So this is your like velocity of a vehicle, coefficient of drag, and the area and air density. So this will be like your constant term, dimensionless. Okay. So yeah, we'll also look into how to calculate this one in the further part. So whatever the first equation which is mentioned in the box, it is a generic equation. So if you want to include like the wind like heavily blowing over your vehicle, against your vehicle, or like you are moving with very high speed against your blowing wind city. Okay. Or you are moving along with the wind of blow direction, so like you have to subtract it from the vehicle velocity. So these are some modifications. Okay. Like there are other drags also has to be included for traction calculation of your vehicle, or like this is like more than enough. Yeah. So we just look into like the factors affecting aerodynamic force. So one thing I need you guys to make a note here, like all the parameters are like directly proportional to the aerodynamic force. Okay. Yeah, that parameters. So if any one of like parameters increases, so obviously the aerodynamic force is going to be influenced. So here the parameters going to right. First we'll talk about drag dependencies. So we were discussing about CD, that is coefficient of drag. So coefficient of drag, like it will depend on your vehicle shape. Okay. So here there are some general shapes. So if the different shapes, like what will be like your drag coefficient, you can just see here. Okay. So whenever we talk about the vehicle, or if you take about a plane, a rocket, all this, all those bodies, like almost a streamlined body. Okay. Or like streamlined half body kind of. Uh, the purpose of going a vehicle manufacturer in the streamline, it is because of having very less drag coefficient comparing to the other shapes of shapes. Okay. So if you just like look into some like a high performance car, so the drag coefficient will be like very less. Okay. So if you just look for some like lorries or bus which is having almost a flat surface, uh, you can just see the drag coefficient like which will be having some higher number. Okay. Yeah. So it depends like what shape we are going to make use for the manufacturing. And the velocity, it is directly proportional to the velocity, that is force. In the equation only we see that all the parameters are directly proportional to aerodynamic force. Okay, so having to get more aerodynamic force. Okay, so like and air density, drag is directly proportional to the air density. So air density, like we define with the help of like rho. So higher the air density, higher will be the like aerodynamic force. But air density will be depending on the temperature. Okay, so if the temperature is higher, the air density is going to decrease. So indirectly, aerodynamic force like is also dependent on temperature through a term air density. Okay. So if you see like in the cold cities, like in like in the north part completely, like Himachal, all this stuff. So there will be like having higher air density. So again, like in the drag coefficient, like there are some different types of drags, like skin friction drag, pressure drag, inference drag. So we can like take it as your assignment part, or like just look into what are the things. Okay, and yeah. Just quickly move to the next part. So as I was discussing about like how to estimate CD value, like we know the equation like for aerodynamic force, that is 0.5 rho CD, and like front end. So like just like transferring all the parameters to the LHS. So it will become like CD equal to AF divided by 0.5 rho CD, not CD, frontal area and V square. So this V square will be like vehicle of your ear. Okay, for this instance. So here you can see, like in some of the tests, a kind of wind is blown over the surface of your vehicle. Over the surface of your vehicle. Know what these parameters, that is rho, like frontal area and aerodynamic force, like they are like fixed values, and with these values, like we are going to estimate the CD value, which is a non-dimensional, like a dimensionless. Okay, so this is how they are making use of it. This is like these two are like real time, and this is completely on the tool base. Okay, CFD simulations like will be like considered. Yeah. So like as I was discussing the equation, uh, just make down this particular equation, so which we'll be using. Okay. Yeah. So don't worry about these equations. So now, like if you talk about gradient, as I mentioned, like if you're moving on the flat surface, like a minimum like effort has to be put by the vehicle. So if there is an inclined road, like we have to go for like more effort, because again it will become like against your gravity with angle. Okay. So like your vehicle. So if you are, let's say like uh, if the vehicle is in flat road, like so vehicle, the weight will be completely uh, with 90-degree downwards. So again, if you are in the incline, so it has to be resolved with some angle. So that where we are going to make use of. Okay. So yeah. So this is how like we can define the gradient. So just look into that equation. So like, before going to ARI standards requirements, so just make a look of here. Yeah. So these are mentioned in like percentage. Okay. So to calculate the gradient force, so we can make use of this equation. So here, here it should be like theta. Okay. So this should be the theta. So here, like in the equation we have mentioned plus or minus GVW multiplied with sine theta. Okay. So here plus or minus the purpose, or like if you are going in uphill condition, then this the gradient force has to be included. Okay. So it's going to like going to influence. So we have to include that effort also. If it is in a downhill condition, so it will be in the favor. So we have to like subtract that complete like force. Okay. Yeah. You can see the scenarios here. Like if you're traveling uphill condition, you have to put effort. If you're like coming down, even if you don't accelerator because of the moment, it will be like coming down. Okay. Yeah. So these are like some set of equations. So we just looked into rolling resistance, aerodynamic, and gradient. Okay, so now like we'll just look into the acceleration force. So here, like how we are defining the acceleration force. So is nothing but that is mass into acceleration. Okay, so here like we are going to include the acceleration force like in terms of sizing. Okay, we should be knowing like how much of acceleration force has to be produced. Okay, so first consideration we have to make like while we are like calculating the force requirement. So one, the force requirement, it has to help to overcome the requirements. Let's say like initial resistance, static resistance, and after that like aerodynamic resistance, rolling resistance. If grade is considered, then grade resistance. So first thing, it has to overcome all the resistive forces. Okay, and then next thing, like it has to produce enough force so that uh, like it can move with the desired velocity. Okay, yeah, okay. While we are calculating the total energy like or the power required at the wheel side, so what are the things has to be included, we look into it. So if we see, if you like we can calculate with the like total tractive force, okay, is multiplied with uh, wheel radius, because torque is defined in Newton meter, right? So like, you might be thinking like what is total tractive force? So total tractive force, like it is the total force like which we it is required like to overcome all the resistances, and it has to move with the desired velocity. Okay, so here we are going to add all our resistive forces. Okay, F Aero, so and getting to know all the total tractive force. Like the total force were minus of wheel radius. Okay, so multiplying with the wheel radius, we'll get wheel torque. So if you consider like wheel to well analysis, so you will get to know wheel torque and also the wheel speed. Okay, yeah, be thinking uh, this should be like subtracting from the total requirement. Many people might be thinking that way, but why we are adding? It is in the backward approach. This is your kind of Newton. Okay, I'm just like taking a random analogy here, and there is some resistance from your aerodynamic force 30, some gradient like 10, rolling a 10. Okay, so on the both side, it means still with the 50 Newton as an effort from this side, it won't help you to a some block or the vehicle to move in this direction. Okay, so if you mention like instead of 50, like 51, so it will start moving with some very small speed. So if you make it like 60 speed. So first 50 Newton, whatever you're applying, that will be like to balance of the resistive forces, and whatever the after that you are applying right to this 50 Newton, that we call it as the acceleration force. So that forces plus extra effort to move so that our body or the vehicle can move with the desired speed. Okay, yeah. So like these are approaches, the same thing which I mentioned in detail. So if you talk about like transmission side, like we'll be using this particular equation to calculate the motor speed and the motor torque. So if this is your like block diagram, right? So vehicle body and transmission, motor, battery. Okay. So output of your vehicle body and wheel speed. So output of your transmission system, you will be getting motor torque and the motor speed. So here, this is transmission modeling, like we can use these equations. So you have to besize this gear ratio, and we're going to multiply with wheel speed so that you are going to get the motor speed, and wheel torque divided by gear ratio into some efficiency, transmission efficiency. So you will getting the motor torque. So if you talk about the efficiency, so let's consider this block. So from source you are supplying some like power here, so 100 watt kind of thing. So here you are going to make use of 90 watt. So the rest 10 watt is a loss, you can say. So it means it is this particular system is 90% efficient. So there will be some loss. Okay. Yeah. So just make note down of these equations for the transmission modeling and these equations. Okay. Yeah. So next, like with a known, let's say like motor torque and the motor speed, will be like knowing the motor torque and the motor speed. So with that, we can go for estimating like, sorry, motor torque and the motor speed. We can go estimating the motor power. Okay. So block diagram, vehicle body, transmission, motor. So here you will be getting motor speed and the motor torque. So with this, you can calculate motor power. So the simple mechanical equation we'll be using. So this is your motor power. Okay. So 2 pi N T upon 60. So N is nothing but motor speed, T is nothing but like motor torque. Okay. So 2 pi upon 60 just for conversion, or like the linear to let's say like RPM. Okay. Yeah. So here you will be like getting motor power. So with this motor estimating the battery power. So if this is a motor, right? And this will be like your battery. So in between there is some motor controller between battery and the motor. So there will be some losses at the motor controller. Okay. So like if you include, let's say like your battery is sending, like I'll take a same example, like 100 watt. Here you will be receiving like 80 watt at the output of motor controller. So like 20 watt kind of waste. So it means like it is 80% efficient. So like this efficiency, like if you include, right, then you will like estimate the battery power. Okay. So let me show it. So is nothing but like motor. Yeah. So you can see this particular equation. You should be knowing motor power. Okay. So first, what we are going to do, output of your transmission block is nothing but motor torque and motor speed and motor torque. So upon 60, you will get to know motor torque, sorry, motor power, which is motor output speed or like motor output power. So if you include efficiency of your motor, then you will get to know motor input power. You are going to divide it with the motor controller efficiency, then you are going to get battery power. Okay. Yeah. So this is how like exactly the flow takes place in terms of equation. So let me show you here. Like with this equation, you are going to estimate 2.0 motor output power, MPP output, and later knowing the motor efficiency, divide the motor power with the motor efficiency, like you will get motor input power. So then motor input power divided by motor controller efficiency, you will get battery power. Okay. Yeah. So this is about like the component sizing, basic equations you can say. Okay. Yeah. So just let us know in the chat box, like if anyone having any doubts or like if any equations you wanted to note down. So yeah. Just let us know. I'll quickly go to the calculation part. Okay. So like I hope you guys have like received this file. Like considering that, like I will just go on solving some parameters here. The equations which we just now like went through, we'll be using the same thing, like same equations. like we'll try to like import that equation here, like represent the equation in Excel sheet format. Okay. Yeah. So before that, I'll just try to explain this or whatever the data which I given, that is drive cycle. Yeah. So I hope you can see this graph. Okay. So with this graph, like we can say that this is velocity and this is your time. So we call it like if you want to define the drive cycle, what is drive cycle? So it is nothing but a velocity upon time. So which will be like including varying velocity values with respect to the time. So let's say like if you're traveling from your home or like house to your college, if the distance is between like somewhat like 5 kilometers, so this is your like destiny point from A to B. Like house to the college. Between them, a lot of things like within like 5 kilometers, a lot of things going to include. Humps will be there. Some straight route, the like some curves road will be there, and a lot of traffic will be there. So you won't be like maintaining the same speed. So like sometimes you will be like going with high speed, low speed, maintaining some constant speed, and again like increasing the speed. Okay. So somewhat you are going to reach your destiny. Like, but the speed values is going to be like different or varying, or like based on the situation. So if you consider like you were like riding, if I discrete this like completely the file, and if I consider the values, we get to know like for each second what can be the value of your speed. So that we are like nothing but representing the time. Okay. So on the x-axis, and y-axis will be representing the speed. Yeah. So this is how we can like represent the drive cycle, or like we can define the drive cycle. So it is nothing but velocity upon like velocity versus time. Yeah. So use one particular velocity, and we can estimate the energy required kind of thing, like motor size, motor torque. We can also calculate speed. Well, but if you want like including the varying speed, so that like you will be like having a varying motor torque and motor speed, so that from that we can get to know what is the continuous torque requirement, the peak torque requirement, the mean torque requirement, all this stuff. Okay. Yeah. So what I'm going to do, like I'll quickly put some vehicle parameters. Here, same thing. Input parameters. Values. Okay. So I'll be like considering V mass, that is vehicle mass, 191. Driver mass, 70. wheel speed. So wheel radius. Like 0.1524. Like they are in meter. Like mass and driver mass, like they are in kg. Grade angle will be 0. Air density. .22. Okay, and the frontal area. Yeah, it is nothing but like 0.87 K ratio, 7.8. Transmission efficiency 0.85. Motor efficiency 0.9. Motor controller efficiency 0.85. And CD, that is coefficient of drag. I'll just take 0.22 and GVW, that is gross vehicle weight. So as we were discussing gross vehicle weight, like it has to be considered. So first we'll mention it, gross vehicle mass. So you can just put a equal sign, select vehicle mass and driver mass. Vehicle mass plus driver mass and say enter. You will end up with some value. So it will add this value. If you change vehicle mass or driver mass here, it's going to affect it here. Okay. So now I'll put G equal to 9.81. GVW. Copy, paste it here. Yeah, this G is nothing but a gravitational force, acceleration due to gravity. Here, just bring a equal sign, select this one, bring multiplication sign, select acceleration due to gravity, say enter. So you ended with some value, like, yeah, 2560. So I'll just make it 11. Okay, so just make a changes in the vehicle mass. Yeah. So this is your like final input parameters which we'll be using. So what I'm going to do, just go back to the drive cycle. Like I'll just copy, come back to sheet 1, put it here. The same thing for velocity, copy, paste it here. So whatever the velocities are there, right? They are in kilometer or like kph. Okay. So now I'm going to like convert into in meter per second. So to make that equal to sign, select, multiply with 1000. Just bring a bracket divided by 3600. Close bracket. Say enter. So I double click here. So just drag till the end of your drive cycle. Okay. So you just converted all your like values into meter per second. So just select this point and drag. Okay. Or you can, even if you double click on this particular point, if I select this one, right? Okay, this dot. So if you double click over with the help of mouse button, it will still like, or like it will show you like up to the end. But yeah, we look into it. So now, like we can calculate like wheel speed here. Okay, we can put up the equation that is bracket v, or like it is nothing but velocity. So we have to select this g2 multiplied with 60 close bracket divided by open bracket to 5 value and multiplied with r, that is nothing but wheel radius. So here, like right, the before value, like whatever now we have taken, it will for the next calculation it will take this value, and the next calculation it will take this value. So to make this, like this particular wheel radius has to be constantly repeated for this wheel speed calculation, even with respect to n number of speeds. So for that, I need to add a dollar symbol. Okay, yeah. Now I can like close, say enter. So just drag. If that doesn't work, just drag. Okay. Yeah. So now, like we'll quickly move to the like other parameters, like resistive force. So I'll just make it aerodynamic force. So I'll just put an equation here. So let me write that is 0.5 AF equal to 0.5 multiplied with rho multiplied with CD multiplied with FA multiply with V square. So let me put this equation here. So 0.5 multiplied with rho. So I have to take rho, that is nothing but air density. So I have to put dollar symbol. And multiply with CD, that is 0.22. Again a dollar symbol, or like the same values has to be repeated throughout your calculation. So I have to use the dollar symbol. Rho CD frontal area add a dollar symbol. Okay, and power, sorry, V square, that is like we can also like, there is some shortcut to v raised to square. Let me check. Select the velocity, bring a bracket, power, comma, 2. I think this should be work. No. Maybe the capital. Just let me check. Okay, it's not working. We can just say that again, bring multiplication, just make it G2 into G2. That's fine. So the velocity will be varying throughout your time. Okay. Now say enter. Okay. Yeah. So just drag it to end. So you'll end up with some results. Okay. So we have like added a aerodynamic force. Now like we'll estimate rolling force. So for this, I'm going to add an equation like GVW multiplied with CD or like CRR. So let me check where we have mentioned. Or you can just put 0.015. Okay, it's going to repeat the same thing throughout your calculation. Okay. I should be adding a dollar symbol so that it will work. Oh, it will give proper results. Yeah. Now you can see. Okay. So let me bring like gradient. It will give you 0 because we have considered gradient angle as 0. So we know like GVW multiplied with sine theta. So it will be like radians later convert into. So whatever the angle is in 0, sine 0, like you will get 0, right? So multiplying with anything with 0, you will get 0 at the end. So gradient force will be 0. So including here, like adding the 0 to some number, it doesn't make any sense. So we'll just try to neglect this one. Okay. Now, like we'll try to bring acceleration force. So we should be knowing how to calculate acceleration from the velocity. So if we define what is acceleration, like we know that acceleration or like it is a rate of change of velocity. So meter per second square. Okay. So if we want to define, like let's say v2 minus v1 divided by t2 minus t1. So this gives you like acceleration. So multiplying with the m, we get acceleration force. Okay. So what we are going to do, I'm just going to assign here V4. Let me bring a bracket over here, minus V2 divided by 2. So why 2? Because if you consider we are considering this velocity, right? And the respect to time, that is 2 minus 0, you will get 2 itself. Next, 3 minus 1, you will get 2. So the 2 is going to be repeated. So I'm just using the 2 here. Okay. Yeah. So if I say enter, I'm going to get some value. Yeah. So this is your like acceleration force. Okay. So now we'll be going for to calculate total tractive force. So just need to add equal to aerodynamic force, rolling force, acceleration force. So just need to add here. Okay. Say enter. Yeah. So here we can calculate wheel torque. Wheel torque. So total tractive force multiplied with wheel speed. So take this wheel torque, add like star symbol here. So symbol, say enter. So like we have some set of data here. Wheel torque. So we have like wheel torque and the wheel speed over here. So with that we can go for estimating motor torque and the motor speed. Okay. Yeah, let me put it here. So wheel torque, wheel speed. Let me bring motor torque. So to calculate motor torque, so wheel torque divided by K ratio multiplied with transmission efficiency. Okay, we need to put this equation here. Yeah. So let me do that. Equal to wheel torque is this particular value divided by into bracket gear ratio, that is 7.8. Add a dollar symbol. Before and after A. Okay. And transmission efficiency. Add a dollar symbol. Okay, close bracket. Say enter. Okay. We are getting. Let me check. So instead of here, I should be selecting 7.8. Yes. If you select the variable that is input parameter side, it will show you some error here. Now if you say enter, yeah. So this is your like motor torque. Okay. So that is gross vehicle mass. Select where it is. Yeah. Say enter. So add a dollar symbol. Now make the changes. Yeah. Okay. Yeah. So let me clear. So let me check. Okay. We added mass. Yeah. Everything is good. Now, like, okay. So let me go here. Motor speed. So motor speed equation. Gear ratio into wheel speed. Okay. This we have to put it here. Equal to like gear ratio 7.8. Need to add dollar symbol and wheel speed multiply with wheel speed. So select this one. Sorry, wheel speed. Say enter. Yeah. Now we are getting some motor speed here. So by knowing the motor torque and the motor speed, we can estimate motor power. Okay. So motor power like 2 pi nt to pi value is 3.142 multiplied with 2 pi nt. N is nothing but motor speed. Torque is nothing but motor torque. 2 pi nt divided by 60. So this will be like your power. Okay. Yeah. Like in watts. So you whatever the power you calculated, right? That is nothing but, let me show you here. This is your like motor. So with the wheel speed and the wheel torque, you have calculated motor output power. So there is some losses in the motor side also. So if you include that, you will be calculating motor input power. Okay. So that is nothing but motor efficiency. So we just include that one. If you include like one more efficiency called like once you get to know the motor input power, right? There is some motor controller. MC is nothing but motor controller. So here motor power input, like batteries from the source, there is some power, like while it's going through motor control, there will be some loss. So we'll include motor controller efficiency also. So you will be getting battery power. Okay. So two efficiency I have to include. One is motor efficiency and the battery efficiency. So motor output power divided by motor efficiency multiplied with motor controller efficiency. So you will end up with battery power. Okay. Yeah. So what I'm going to do, I'll directly put battery power here. So equal to, let me go to input parameter side. So motor power divided by into bracket motor efficiency multiplied with motor control efficiency. So close bracket. Say enter. So what mistake I had done? I had to include like dollar symbol for efficiency. Yeah. Now this is your like battery power. Okay. So if you consider this is your thing, right? Let me check here in the graph. Okay, this is your velocity graph. Okay, or like directly I'll take you to torque. So this is your like torque, motor speed, battery power, so motor power and the battery power. So here you can see how the torque characteristics are there. Like we know, like the torque is like directly proportional to your acceleration part. So like if there is a lot of load, like in initial conditions, like a lot of torque is okay. So as the speed increases, the torque will also decreases in the vehicle. Okay. So this is your like motor torque requirements, and this is your like motor speed requirements. So you can see like based on the torques and the speed, there is a motor's power. So you can see at higher RPM of your motor, there is a high power requirements based on RPMs and the torques. You can see like what kind of power or characteristics are required. People might be like wondering what are these negative part. Okay, so let me show you that one. So in the acceleration part, So this acceleration force, from the velocity we derived the acceleration and then we multiplied with mass. Okay, that is the constant value. So let's consider that it's acceleration. So if we know, like, if the velocity is constant, your acceleration will be 0. Like if your velocity is like increasing with some rate, so that will be like your acceleration. It will be in the positive side. If your velocity is decreasing, then it will show you the deceleration. Okay. So in the same way, like while we are like calculating the torque power, like you will be including like your acceleration, right, which is the directly proportional term. So this is your like torque. Okay. So if you talk in the EV, this you can consider a region, a maximum possible region that we can estimate from this particular drive cycle. So the same thing with respect to the power here. So this is the power which we can measure from your region. Okay. Yeah. So here, let me. Yeah. So let me bring the velocity. Okay. So if you see your like velocity graph, so like you can just compare, like when there is like increase in the speed, you can see the spikes. You can just try to compare that in the decreasing phase. You can see the fall. The same thing you can see with this one. So there is an increase in speed, and respect to time, there is some like spike in the motor torque, and the same thing here in the like completely decreasing speed. Like there is completely so it's a negative torque. So if you talk about like acceleration, like it repeats the same pattern of graph, right? Okay. So whatever the above, the positive, this is the tractive force required, and this is the possible tractive, like not tractive, energy can be generated. So the power can be generated. Okay. So like this is a range like from 4 to 6, like 7. Your range is of torque is required. You can say it as like torques values. In the same way, the speed, sorry, like motor speed, I have deleted the graph. Let it be. If you talk about like motor torque, like this is the max power is required, and this is the continuous or the average power is required. Like there is no such fixed value, but you can mention in the range. So whenever you are going to ask like a supplier, so he will ask all these parameters like what is motor torque, what is nominal torque of motor required, power, max power, all this stuff. So yeah. So the same type of calculation will be done for different drive cycles. So this is the drive cycle which it is done for highway. So there is also some like other drive cycles like city ride drive cycle. Again in the city there will be like different drive cycles like urban, rural, and other stuff. So yeah. Like all for all the types of drive cycles, we'll be like collecting the like what we say, the velocity values, or like with respect to the time, and we can go for checking, putting it in some calculation, and go on checking for torque requirements. We can estimate the torque requirements and the like motor requirements and the battery requirements. Yeah. So we have estimated up to battery power. Further integrating with the time. So multiply with the time, you will get energy. Yeah, that you can like take it as a kind of assignment part. So just let us know, like if you have any questions regarding. If no, like we'll try to like provide this Excel sheet to you or to the participants. Yeah. So just let me know, like take your time, like yeah. Yeah. So we join to get. I'm looking in some session. So please explain VLDC motor using. Like it's completely into like the other sector. If you talk about BLDC motor, okay. So like algorithms will come up as a part. Okay. So like it's completely into the other sector. Okay. So here in terms of sizing, we'll be using only like uh, efficiencies, losses, or like the requirements. Okay. Um, yeah, it is the same thing. Like it depends. Okay. So here in terms of modeling, right, or like sizing the components, we won't be involving like such that like BLDC, like PMS motor kind of thing. Okay, we are not including any controller algorithm here. Okay, so as in terms of like sizing the components, these are the parameters has to be considered. Okay. Uh, yeah. G angle is nothing but a grade angle. So as I explained, like if your vehicle going in uphill condition, like some angle like is there, a kind of slope you can consider. Okay. So this is going to like affect in such that it's going to make you put some extra effort to climb up the hill. So if you know that angle, okay, we'll get to know at what angle the vehicle like we can like at what angle the GVW like is in the direction, so that we can resolve with the same angles. We know these like both angles will be equal at here and the here. Okay, so GVM like in the slope condition, like it will be in this direction, like uh, complete 90-degree with respect to the vehicle, or horizontal to like surface or slope surface. So in this, like it will be uh, in angle, so it has to be resolved. Yeah, that angle like we need to find. So this is like gradient angle. Okay. Yeah. Yeah. Just let us know, guys. I know like I've been like fast because of the time constraints, or like it will take some more time. Just try to spend more time on these things, the calculation, the equation part, so that you will grasp the things. So it will take some time to digest. Yeah. So let us know, like if you have any doubts, or like in terms of like sizing the components, or like if you want to know some other like other things, just let us know. Or like we can also like model the same things in the help of tool called MATLAB and Simulink. Okay, so there or like you will be having like much of flexibilities in terms of plotting the equations, or like studying. Okay, yeah. Now just let us know in the chat box if you want. I will show those models. Just let us know in the chat box if you want to like see the models how they are like built in the MATLAB and Simulink. I'll just show you. Yeah. So like if you are done, you can just quit the session. Okay. can catch up with the next part of the session. I'll just stop sharing the screen.
Thank you, sir, for this informative session. Now we have the third session at 2:15 p.m. and it will be delivered by Mr. Srinidhi, sir, Senior Simulation Engineer, Decibels Lab.
Yeah. Okay. Like